So following on from the previous video, we now need to look at the arc length in parametric form. We've already seen this, now we're going to look at this. And then later on we can combine the two to extend it into 3D, and then from 3D we can try and understand why the arc length is given by this. So now let's look at it in parametric form. So in parametric form, let's say you've got a curve given by this, and let's just say A is somewhere here, this is A, and B is somewhere here, B is somewhere here. So you've got a particle moving along this path. So the idea is this is time, everything's driven by time, so we're going to cut up into lots and lots of different segments, and then let's just say this is K here, and this is K minus 1. So this, when time is here, then this will be your K here, and then this will be K minus 1 here, which will be this point here. So you cut up. Let's just imagine it as this. So this thing here, let's just say it's here, and then when time is at this point here, the particle is here, and then in parametric form, this tells you the x direction, the location of the particle in the x direction, and then this thing here tells you the particle in the y direction. So we can imagine f of t as a graph, a function in terms of time. So for example, if this is 3 and this is 7, say, what that means is this. Remember, f of t tells you the x location. So if this is 3, then well, this thing here is actually talking about this bit here. So this will be 3, and this will be 7. And then if you look at this here, let's just imagine this is 2 and this is 5 here. So this height here represents the height here. So the y, so when it's 2, this will be 2, and this will be 5. So the height here, hang on. So the height here talks about the height in the y direction, and then the height here talks about the width in the x direction. So now if we want to find the arc length, we're going to so this is our length here, all the way like this, split up into lots of segments, split the t into lots of different segments. So right here it correlates to this point here, this bit here relates to this point here. So we want to somehow obtain this diagonal length. Well, the diagonal length for this segment, which is this diagonal length here, so this diagonal length here is given by this thing here. So we would get dx delta x. We would get delta x for that particular k segment. So remember, this is k here, and this is k minus 1. So for this period of time here, we want to know this diagonal length. Well, the diagonal length will be delta x, square it, delta y, square it, take the square root. It's basically us using Pythagoras to work out this diagonal length. Now, if you look at this, delta x, we can imagine it as this. We can rewrite delta x as this, because if you look at this, x is given by this function. This function is like this on this graph. So the height here represents delta x. Well, the height would be f of t minus the f of t previously. So hang on, so we would cut this up like this. So this is k here, and then this is k minus 1. So when tk, this is tk here. Hang on, this is tk right here, and this is tk minus 1 right here. So this height here, well, this height here represents delta x, which can be written as this. And then if you look at the delta y can be written as this, because delta y, the change in the height, is given by this height here, which is hang on, which is, let's say this is k here, so GTK is this, take away GTK minus 1, which is this bit here. So I hope you can follow this. Well, this whole thing here can be written as this. Okay, so hang on. So I will continue in the next video. We are currently here. Okay.